All right, let's go ahead and do page number 3 in the packets. So it says complete the charts below to graph each function, label the angles and radians along the x-axis, the values of the functions along the y-axis. Use the unit circle to help get the values. Okay, so here we are going to go ahead and evaluate sine of theta. Our thetas are listed up over here. So all I'm evaluating for the first one is sine of 0, which I know is right here, right? That's 1, 0. We just get 0. Right? Sine of pi over 4. I know this is just radical 2 over 2. Sine of pi over 2, right, is 1. Sine of 3 pi over 4 is radical 2 over 2. Sine of pi is 0. Sine of 5 pi over 4 is a negative radical 2 over 2. Sine of 3 pi over 2 is negative 1. Sine of a 7 pi over 4, right, is that negative radical 2 over 2. And then sine of 2 pi back where we started is at 0. Okay, so we just use the unit circle to get these values. I'm going to go ahead and label the angles and radians along the x-axis. So I'm just going to go ahead and take all of these guys and put on the x-axis. So starting at 0, I'm going to have pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, 2 pi. Right? And then I can go ahead and use these guys. These guys are my y values, right? So as I'm building up my graph, these are my ordered pairs. So 0, 0, this is my first point, right? I have pi over 4, comma, radical 2 over 2. If I were to go and plug that into the calculator, and I could go and pull that up. If I plugged in radical 2 divided by 2, that gives me like 0.7. Let's call it just 0.7. So I know that this is approximately 0.7. So here's 1, here's negative 1. It's going to be somewhere right there. Right, pi over 2, comma 1. 3 pi over 4, comma pi over 2, back at that 0.07. Pi is at 0, 0. 5 pi over 4 is a negative 0.7 value. It's like call right there. 3 pi over 2 is negative 1. 7 pi over 4, back to the negative 0.7. And then 2 pi is back at 0. Now we have created enough plots, right? Enough points where I can go ahead and start drawing in this function. Cool. Obviously, if we kept going, right, we would keep going with this graph. Okay, but what we want to go ahead and focus on is this guy right here. Is this one period, right? If I were to continue on, right, this pattern would just keep going and going. So this is my 1 period length. Okay, so I just answered the first question for you, is what is the period length, right? If I start at 0 and I go all the way until my function continues with this pattern, right, it looks like I have a period of 2 pi. Right, my amplitude, I'm just going up 1, right, down negative 1. My y-intercept is at 0, 0, which is just the origin. I'm going to skip x-intercepts for now. I'm going to explain that later. Right, my domain, if we continued on, right, it would be all real numbers or infinity towards infinity. And then my range, right, is I'm going to keep going back and forth between negative 1, 1. And these guys have hard brackets because negative 1 and 1 is included in my graph. Okay, the x-intercepts, we see that I have 0, 0, right? That is just like my y-intercept. And then I have another x-intercept at pi and another one at 2 pi. If I were to continue, it would always hit some value of pi. So the way that we express this, right, I can literally go ahead and actually name them all. So I have 0, 0. I have pi, 0. I have 2 pi, 0. Right, it would keep going, yada, yada, yada. The way that we can express this as is pi times some number of k, some integer, comma 0. And this is the kicker, right? I'm going to go ahead and say where k is in the set of integers. This notation right here, guys, k, like we said, is just an integer. K is in the set of, this is a symbol. It's like a little, I don't know, a little T guy. This means in the set of, and then this Z is known as an integer. Okay, and integers are just like positive, negative whole numbers. Okay, so now we can go ahead and say, yes, the list goes on and on, right? If I were to go in the negatives, it could be a negative pi, comma 0, right? It keeps going on and on and on in both directions. So all I have to do is take pi times some integer value of k, comma 0, where k is in the set of integers. Okay, that is our new notation. All right, let's go ahead and do, so this is the sine graph. Okay, this is your parent function. Whenever I say parent function of the sine graph, I'm looking at a period from 0 to 2 pi, and I'm looking at these values right here. When you guys are graphing it, all I really need to see is your first initial one is pi over 2, comma 1, pi, comma 0, 3 pi over 2, comma negative 1, and 2 pi, comma 0. Those 5 points are the only ones that I need to see. Okay. All right, let's go ahead and focus on cosine of theta. So same exact thing, right? These are your x values, right? So I can literally go ahead and jump in and put these guys on my graph. And we will get very much so into practice. So this just becomes like your muscle memory, to be honest. Okay, and then I'm going to go and evaluate each one of those. So cosine of 0 is 1. Cosine of a pi over 2, or sorry, pi over 4 is radical 2 over 2. Cosine of a pi over 2 is 0. Cosine of 3 pi over 4, negative radical 2 over 2. Cosine of pi is just negative 1. Cosine of pi over 4 is negative radical 2 over 2. Cosine of 3 pi over 2 is 0. Cosine of 7 pi over 4 is a positive radical 2 over 2. And then cosine of 2 pi is back to 1. Okay, so I can go ahead and start graphing these guys as well. So my first point is 0, comma 1. So I'm going to put 1 and negative 1 on the graph. There's my first point. For pi over 4, again, I'm going to evaluate this guy at 0.7. At pi over 2, we get comma 0. 3 pi over 4, we have a negative 0.7. At pi, we have negative 1. 5 pi over 2, or 5 pi over 4 is a negative 0.7. 3 pi over 2, we're at 0. 7 pi over 4, we're at a positive 0.7. And then 2 pi, we're back at 1. And now we see that we have this kind of like valley shape. Whoa, valley shape kind of function. Okay, again, when you're graphing it, right, I really just need to see these 5 points for your parent function. And obviously the shape of this valley. Okay. All right, the period is the same exact thing, right? If I were to go and continue this, it would go down that way and it would go down this way. So the period is the same thing as sine of theta. This is just 2 pi. The amplitude is same as sine of theta. It's just 1. The y-intercept, right, we have 0, comma 1. I'm going to skip the x-intercepts for just now. Domain, right, we have all real numbers or infinity, negative infinity towards infinity. And the range, same exact thing. I'm going between negative 1 and positive 1, where both these values are included. So I should be having hard brackets. Okay, now the x-intercepts, right? I see that I have pi over 2, comma 0. I have 3 pi over 2, comma 0. If we kept going on and on and on, it would have some kind of variation of a pi over 2. Okay, so this one is actually expressed as, I'm going to start with pi over 2, and I'm going to add however many pi's times, again, this value of k, where k is in the set of my integers. So, right, if k was 0, right, then I would have pi over 2 plus pi times 0, which would give me to pi over 2 plus 0, which would be pi over 2, comma, 0, right? Let's go and say my pi was, or my k was 1, right? So I have pi over 2 plus pi, right? I would go ahead and find a common denominator. So this is really saying pi over 2 plus 2 pi over 2, which would give me the 3 pi over 2, right? Again, you're just adding however many pi's to get your next value. So that is how we would express the x-intercepts.